This is Chemistry Chapter 10, Lecture number 3, the last lecture of this chapter. Should be the shortest lecture of the 3 lectures. We're going to talk about titration. So we are on page 6 of your notes. We're only going to do one problem today, so we're only going to be on page 6. In the book, we will be working a problem from page 345. Right now, this is very important. If you're watching this video, that means you didn't get the lecture in class. You need to watch the video linked in the description box. All right, so watch video in description. Okay, I'll have it linked there to show you an actual demonstration of a titration. Okay, I'm going to do that in class, but this will make a lot more sense if you watch that video. All right. Now, going through the notes real quick. So what titration is, and it's a pretty fun process. This is one of the best labs that we do. It's slowly reacting a base of unknown concentration with an acid of known concentration until just enough acid has been added to react with all of the base. So what happens is you're taking an acid, adding a base to it until the solution is neutralized. All right, we will have an indicator in the solution, and as soon as that indicator loses all its color, then we know that we can stop the reaction. Okay, so after titration is complete, stoichiometry is used. So this is a stoichiometry problem to determine the concentration of the unknown. We're going to have a solution that has an acid-base indicator in it, all right? So it may be, in our lab, it's going to be pink. And when all of the pink goes away, you know you've reached the end point of titration. And we're going to use a piece of equipment called a burette, all right? You learned this in the very first week. What a burette is, a long piece of glassware, and it's precise to 1/100th of a milliliter, so it has a lot of markings on it. Okay, it's really cool. It has a valve at the bottom and allows us to slowly drip one solution into another. Okay, so I want you to write, I've done it at the bottom, so skip down to the bottom of page 6 and write out these titration steps. I've kind of put a lot of pages in the book. I've condensed it down to 4 steps. Okay, so this will save you a lot of reading. And then we'll work the problem above that. Okay, so titration steps. So step 1 is we have to get a balanced equation. All right, so it's a stoichiometry problem. It's always just going to be a 2-stepper, though, because we're just going from moles to moles. But we're going to get a balanced equation. We're going to determine the moles of the known substance. So you will always know the concentration of one of the substances. It can be the acid or the base. And the way you do that is moles is equal to molarity times liters. We're rearranging the molarity equation like we did in lecture number 2. Step 3 is we're going to use stoichiometry to determine moles of the unknown substance. All right, and the cool part of this, we're going moles to moles. It's always, it's always a 2-stepper. So just 2 sets of parentheses with stoichiometry. And then finally, we're going to use the equation molarity equals moles over liters to determine concentration of the unknown. So our last step, we're going to figure out moles. We know liters from titration. Moles divided by liters will give you the molarity. All right, pause the video if you need to catch up. And we will work problem 10.10. Okay, so I presume you've watched the video now. In the description box, you kind of get an idea of what titration is. And so now we are on page 345. Reading through this, it says, if 125 milliliters of nitric acid with unknown concentration, so our unknown is the acid, is titrated, that just means it's mixed, very carefully mixed, against magnesium hydroxide, which would be a base, right? A hydroxide is going to be a base with a concentration of 2.3 molars. It takes 35.4 milliliters of the base in order to reach the endpoint. What that means is the base was in the burette. We dripped it down into the acid, 125 milliliters of the acid, and in order for the indicator to change colors, it took 35.4 milliliters of that. What is the concentration of the acid? We know how much volume we have of the acid, but we don't know the concentration. All right, step 1. We've got to get a balanced equation. All right, so 10.10, page 345. All right, our balanced equation. So we've got our acid, HNO3, plus the base is magnesium hydroxide. Now, when you go through the process, remember magnesium's 2+, hydroxide is just minus. After the switch, that'd be MgOH2. This is reaction 1, the neutralization reaction. So we know we've got water as a product. The salt is going to be made of magnesium and nitrate. Remember, hydrogen and hydroxide make up the water. The salt, magnesium. Magnesium would be 2+, nitrate 1-, so it's going to be MgNO3, 2. So you're putting those together just like in Chapter 9. All right, right here and right here, we had to use our Chapter 9 knowledge of polyatomic ions and charges to put those together. Now, it has to be balanced or you can't do the stoichiometry. I've got 2 nitrates. I've only got 1 here, so I'm going to put a 2. All right, I've got 4 hydrogens now, so I need a 2. There, and now we're balanced. It's really only important that you get the reactant side properly balanced. Let's write down what we know. We have 125 milliliters. This comes from the problem. On magnesium hydroxide, its concentration is 2.3 molar, and it took 35.4 milliliters in order to reach the end point of titration, to neutralize that acid. We want to know what is the concentration of the acid. We have the concentration of the base, 2.3 molars. What's the concentration of the acid? We can figure that out just by mixing them together. Okay, first, I need to get the moles of MgOH2. I got enough information. Moles of MgOH2 is going to be molarity times liters. Now be careful, this is in milliliters. We've got to move that decimal point 3 places to the left. So that's 2.3 molars times 0.0354 liters. Move it 3 places to the left to get liters. All right, that is 0.081 moles of MgOH2, magnesium hydroxide. Now we're going to go to stoichiometry. We know the moles of magnesium hydroxide. We need to get moles of HNO3. So just a two-stepper. Always a two-stepper with stoichiometry. Right, going from moles to moles. So this is why we need that balanced equation. We're going to moles of HNO3, getting rid of moles of MgOH2. Use the coefficients. Got a 2, got a 1. So we're going to multiply 0.081 times 2. That's 0.162 moles of nitric acid. That is not the answer, but we need that to get the answer. We want to know the concentration. It's moles per liter. Do we have moles of HNO3? Yep, we just figured it out. Do we have liters? Well, we have milliliters, so surely we can get liters. So it's 0.162 moles over 0.125 liters. How did I get 0.125? I moved the decimal place 3 places to the left to get liters. 0.162 divided by 0.125 would be 1.3 molar HNO3. So pretty neat trick. All I had to do was mix those acids and bases together with an indicator. Once that indicator changed colors, HNO3 was neutralized. And since I knew how many milliliters I had, I knew the concentration of the base, I can get the concentration of the acid just with a couple of calculations. Okay, the homework for titration is we're just going to complete the review questions and the practice problems. All right, so review questions on page 351. You can do number 10. Number 9 is related when you did number 9 on lecture 2. Maybe I jumped the gun on that one. And practice problems, page 352. You've only got 2 problems. They're both titration problems. So that is number 9 and number 10. You know it's a titration problem if it has the word titration in it. If it doesn't have the word titration in it, it's not a titration problem. It's probably just a stoichiometry problem. Both of these problems have the word titration in it. Okay, so we're going to go over these and in class and then do the lab, and the lab will make a lot of sense after we do a couple of these problems. So that completes chapter 10. And do that homework 10 and 9 and 10, and you will be good to go for the titration lab. See you next video.